Yeah. So which one, which part is your question?
Part A.
Part E.
Yes.
Okay. So use the training data to sample from the posterior of the SIR model. So whenever we say, I think there was also a question before, so I'm going to talk about what is a posterior and what is the, like, the kind of the like. So where the likelihood gives you, it's a function, it's basically the distribution function that captures the how likely the parameters, like a given parameter, how likely that is, so, or how likely is the data to be observed for a given parameter. So that kind of is encapsulated. And normally the likelihood is basically what we call the data generation model. So that kind of captures the data generation, and that data generation in this case will be the SIR model. And the posterior is basically just you have the prior. So when that is multiplied, that's basically what we call the posterior. And finally, like your training data, I think there is some writing, it's not that clear. I don't know why I even wrote it like that. But what it's saying is that the data that you have led to a posterior distribution, and now you have to basically actually visualizing. So it's actually, you should visualize the posterior of the model. So just, and that posterior is basically the lambda parameter, the what it's called. No, actually, so you have the lambda, like, let me be clear. So you have the data. Now you have the model, which gives you a distribution for your parameters. Now, if you sample from these distributions, then you can generate a type of model for the data, right? That fits the data. So now if you plot and plot and plot on top of them by sampling from the posterior, then you get, basically you will have your data as points and your models as different types of models that are sampled from the posterior. So just to explain that, what I mean, this is exactly that what is happening. So do you see here? So these are the data points, while the curves that you see, like these shapes, are actually constructed by drawing from the posterior. So when I say posterior, usually this is posterior, you know, this distribution is mu, the posterior of for mu, and this is for sigma and others. And then these are the data points, and the sample, the posterior, like from each of them, if you draw one mu, one lambda, blah blah, and then plot, it is one curve in this plot. If you sample another one, then you plot again for that, what the curve that you will get for that, you get another one. So this shade is constructed out of it by sampling up the parameters from the posterior. Does that answer your question? So all these are done like that. So the shades are posterior samples, it's called, but it's the parameter you get from the posterior sample, and then with that sample point you plot a curve together with the data in the data space. So does that clear? Or if anyone can ask, if it's not clear, if it's kind of like jargon, technical, whatever I said, ask me. But is that clear? Who is asking that? Ada?
I don't understand.
So I didn't know who asked the question. Who asked the question?
Yeah,
that's Stephanie. Okay. So was that clear?
Yes, it has helped me a bit. I think I need to do more reading.
Okay, I will also just write it in terms of, like, I think it's not that very clear. It's use the training data to sample from the posterior of the SIR model. This is really badly written. So
because what I thought was, you're using the training data for the prior and then the validation for the posterior, but I think I got it wrong. So
Yeah, I think so. I'm going to plot the training data together with the model that is sampled from the posterior of the SR model, and I will explain that what that I mean. And that is the posterior of the SIR model means on the lambda mu and parameters curve is I think that probably gives you, and I will try to make it even more clearer. What I am asking is just simply for anyone who has not been clear, let me get, so you get this kind of posterior distributions for different parameters. When you take one from that, or like a single model, basically means a single curve. But because this is just a single model, means one single sample from each of them. But now when you sample many times, you get many curves. That basically gives you the kind of your model's confidence around the data. So that's what it means. Okay. Any other question?
So, sir, was that the graph you just showed us now? Was that a sample also?
So like one curve. So 1 point in this space. Let's take lambda, right? Lambda naught.
Yes.
So 1 point. This is a multiple point, right? These are number of, like, lambda range from I don't know, points 3 probably, or 0.35 to 0.5. So 0.3 to 0.5. Okay. Let's say, and then the peak is around 0.4, right? 0.43. So lambda naught 0.43, just that 1 point is one curve in this plot. Like if you, of course, the same 1 point from each of them. So this is a multi-dimensional. So I'm talking about one dimension, but from them, one single point in that multi-dimensional space would give you one curve, one single curve. But if you sample 100, you will get 100 models, and when you calculate usually the variance, that's what you're computing. If you want to put error bars, error bars are like the uncertainty of the prediction around that, then you must sample 100 or 1,000 from your model and then compute the variance around that point, and then that will give you the error around on your prediction at that point. So is that clear? Does that answer your question?
Okay, so what we are expected to get from that question is something like this that is plotted here. Is that?
Yeah, exactly. Absolutely. Yeah, that's it. Okay. That's all I ask you. That point is exactly get a curve like that.
Okay, so from here, sir, from here, the results we get here, are they supposed to help us optimize our model? Like for the approximate, are we supposed to edit our model and put these new results now? I don't know how.
Yeah. I mean, so the process is that when you change the data, of course, you train and then you get a new model. So whenever a model is, basically just once you train, you get some values to your parameters. But those values are distributions in this case, because we are working in the Bayesian sense, it's not a single. If we were working on another regression, linear regression, for example, you get single value for each of the model sometimes. So that's a single model. When you are in a Bayesian sense, you apply with a family of models. of course, a single value or the best fit value is the one that corresponds to the minimum likelihood, or or the maximum likelihood, or whatever you call the peak of your distribution. So everything that's given here, lambda naught 0.43, whatever d 11.4, all these are actually like a single point in your model, but your model is a family of model. Okay, so I don't know if I'm answering your question, but when I ask you, you generate
Okay, sir. Okay,
from
sir.
your data, you generate your own model. It's going to be similar, very similar, but your values are different. That's
Okay,
what's
so
called a model.
okay, so thank you, sir. So if this does not fit very well in my own model,
Yeah.
I'm supposed to change my parameters, right? If this does not,
I think I would say yes. I think that's for many reasons, right? It definitely will fit, but it's not the fitting that's important. I think the model is flexible enough; it will fit your data. The problem will be, can it predict better? That means if you are now using the model to predict for tomorrow, what would be the uncertainty around that?
Okay, sir. For example, yeah, it did not fit perfectly with the density. Yeah, I'm seeing the first spreading rate. Yes,
This one?
Yes, the spreading rate here is not fitting perfect. It's like somehow slanted, and also the change time for the first one is not.
Yeah, I mean, so exactly. So this is a reasonable fit within the error. So the problem is that they didn't show the error bar. But if they would show the error bar, so no, this is actually a confidence interval. It's a 60 or 95 confidence interval, which means 95% of the models are within that range. So you could see, of course, some data points are not modeled well. Yes, but that is not your problem. I mean, as long as it's okay, it's fine. We can't fit everything. That's called overfitting. If everything was fit, then you would have to be worried, because then it's really overfitting. That means it's gonna be like very hard to be good in prediction. So you don't want that.
Okay, sir. So when they mean 95% fitting, they mean for the whole model or for some particular variables in the model, sir, or for particular functions?
I think I would say just whatever you would get at this point. If you have any issue, then let me know. But I think the model is quite strong enough. That's why I didn't ask anything about the model. Whatever fit you will get, it should be reasonable.
Okay, sir. Okay, sir. Thank you very much, sir.
Okay, but if you have any issue, if the data points are like lying around there and the model is whatever, then let me know. Then we can talk. But
okay, I'll show you what I've done, sir.
Yes, I think that would be good. If you can share me even now, I can use it to show to other people so that we can discuss it. But yeah, share with me.
No, I'm assuming it's possibly because I did not do a lot of me and my team. We did not. Where's Adnan? Okay, it's not here. We did not do a lot of tuning. I don't know. Let me.
Yeah, I think the model doesn't need that much tuning. It's the data that, I mean, that's where I'm saying I want you to focus more on the data part than on the model part. It's almost always the play. You can make the data to be closer to the model, or you can make the model to be closer to the data. Of course, almost always in many analysis, what we want is the other way. We want the model to fit the data. And deep learning is one big, one of the reasons why deep learning becomes important is that you need to change little on your data, and the model would incorporate everything. While sometimes in this project, what I ask you is to clean your data such that it is, it's a clean data, which by clean data means it represents transmission diseases that happened, or the COVID cases that happened in the community. That's where I mean clean it. I mean, nothing more, and doesn't have whatever. So, and if there is a missing date, maybe just interpolate it or something like that, such that you get reasonable data. That's what I mean. In this case, that's what. Okay, so I think that's probably clear. But okay, so are these questions new or they have been there? I just didn't open before, so.
So sorry, whilst you look at the questions, what do you
Yeah.
mean by they shouldn't be missing dates? Is it that, let's say for the case of Ghana, you realize that there's a record on, or there's an update on probably today, and then
Yeah.
the next record comes in 2 days time?
Yes.
So is that what, like, the
Exactly.
date in between? The date in between must be filled.
Exactly. You must fill the date in between because the model assumes dates are continuous. So that means every single day by single day. So you must make sure that there is a value there. It can be even zero, but I think you know it can't be zero if it's really missing. In this case, that's where you really need to fill it like with interpolation. So it's because it's a data, that's a continuous thing. Usually when something is continuous, we do it with interpolation. So that means we try to fit, you know, we regress it, or we do some linear regression around it to find the values, you know, for those two missing values. So yeah, is that clear for everyone?
Yes.
Yeah. So make sure that your data is continuous, that there is no missing date in between your training. If you can't do that, I would say just cut everything from some point where you have actually a very clean one and just use that, because the model really thinks that the difference in dates are 1. So that's important.
Okay. One more thing. Won't it be a problem if I use the same model over and over again? Let's say for task 2, which doesn't say anything about we splitting the data into training and test. So I just use the entire data and I run the model, and I'm using the same model. I haven't changed anything. I'm using it to.
So
now,
which one you mean? Like, so you have task 2.
Yes, task 2.
Yeah, task 2. I mean, so like task 1 didn't require you to produce any model.
Okay.
I mean, task 1 was all about writing, right?
Yes, I understand. Task 2, from task 2.
Yeah. So you're going to use one model, like you're going to produce one model, which then, I mean, all this is to just let you construct one model. And once you construct that model, you will answer task 2.2, which is basically, you know, the result, interpreting the result. So task 2.2 is more about interpreting the result.
Can you say something about task 2 itself, not 2.1? There's something up before 2.1. What are we supposed to do there?
No, there's no task. It's more, I mean, this is just
an instruction.
task,
okay.
An instruction what to do, like, and then the real tasks start from here. This is more like prepare yourself for modeling. So that basically means, like, you know, fork it, blah blah, and I mean basically install it in your computer or wherever, and then yeah. So and then this is a summary that what you will do. So interpret the result and write up your finding is basically is going to be what is covered in task 2.2, and adopt the notebook to run a similar analysis is what is defined in task 2.1. So this is a summary of what you are going to do.
Okay.
Is that clear?
Yeah.
Okay.
So I was wondering if you go over the curves again, the output you were showing from the reference paper. Okay. That's not too clear to me. Yeah.
So because I'm not reading when I'm projecting. If people have question, either someone read it for me or just say it. Okay. So this is this one, right? So are you talking about this one, right?
Yes,
okay.
Please.
So I'm just gonna get if there is. Just get that one. Website bar. So this is the real, you know, basically just what is outputs from, and this happens because if you are plotting this, the green, the dark green one is actually what is the mean. So, or in a distribution that would be basically the peak, right? And then these gray, like the kind of light green ones, are the kind of what we call the percentile around it. So it's basically just each of them, whenever you sample from that data and you model it, you kind of run it, that's what you get. And if you take 95% of the model, or if the sample is 95%, then this range basically gives you the 95% confidence interval. So when we say 95 confidence interval, it means from your distribution, from your posterior, you sampled 95% of it, and then you put them, you plot them, and then that spread contains 95% of the model. Okay, and of course that usually when you do sampling, it's kind of yeah, it should be sorted, blah blah. But I think yeah, that doesn't matter. So yeah, and then these are the data points. So this is actually plotting the daily new cases. It's not this is the cumulative, and this is the daily new cases, right? So it's basically the model is what is shown in green, in dark green, and in light green, and this is what we call the prediction. So they start predicting. So they stopped their model on probably, I don't know, 20 April, and then they predicted for the next until 3 May. So that's what the prediction. That's why you don't see data. And the same also here. And now to measure really if this model is good or not is to go and compare. Like now you have the data because you observed the data. If you see them, do they fit here? If they are here, if the data points you observe are here, then you say like this model is bad. I mean, what do you do? That's why you need to use a validation, because this is more to test your validation. You can't just go on your test. I mean, you have to know why we split training, validation, and test. Usually, if you are changing your parameters, you don't want to use the same data. So that's why we always have a validation where it will help us. That validation part is to help us fix our models, you know, the type of model we do. And then the test must be always just only presented to test the model and to get a statement, bad model, good model, that's it. And you can't use then that information to go back and remodel. So that's why we always use a validation one. But so yeah, does that answer the question? Maybe that I'm talking too much and maybe I'm not answering. But does that answer your question?
Yes, a bit, but I still have confusion as to so all of these things, let's say, were they generated from the same parameter? Let's say, okay, I'm looking at the total recovery. Let me see.
This one.
Yes.
Recovery. And this is not reported. Yes. This is reported. Yes. Everything is reported. Yes. Okay.
Okay. So we have functions that were defined to help us get this. Am I just
no, but all these are generated from this. So what you get, the model is here, like the one on the left side. So the model gives you parameters. It doesn't know anything about your total cases, blah, blah. The model knows parameters. Then the model knows how to relate these parameters. So that is what is the model is, the SIR model. So this is the SIR model. So the model only knows parameters, right? And the only unknown parts are these parameters. So because this model is a time every day. So once you start with ST, like let's imagine a time T naught. So you start with S naught, the previous day. And then to predict the next day, the only thing you need is just this lambda in this case. So to predict the new cases, you need lambda. Okay. To predict the new recovered one, you need mu.
Okay.
That's it. So the model, as long as you give it lambda, a value of lambda, then it will tell you what the number of cases will be tomorrow.
Okay.
So what the model is doing is that it takes this thing, it takes the training data, and it tries to find lambda that satisfies that data. And mu, so it estimates everything together. So it's not separately, but it estimates everything together. So finally, then it will give you this kind of plot. Basically, lambda, it tells you, it has this distribution with a peak of 0.43, but it has this distribution. because lambda is not now one number, but as a distribution, of course, if you choose lambda to be here, let's say 0.3, you will get one curve. If you choose somewhere here at the peak, it's lambda is equal to 0.43, you get another. If you pick it here, let's say 0.45, 0.46, you get another model. So because as soon as you specify what your lambda is, you know what is the number tomorrow. And this is a cumulative. Cumulative means it's like basically you are summing. This one is not cumulative. This is new cases every day. Cumulative is basically when you are summing for the next day, you sum everything before it. For the next day, you sum everything before it. So that's why it always increases. Cumulative curves increase because this one incorporates all the cases so up to this point. And this one will incorporate everything. So this is a transformation. This is not a model. It's the same model. You basically take this one and you do cumulative sum both in the model and in the data, and you get this. So there's nothing new. It's the same model that you're using. Does that answer your question?
Yes.
Great.
Hello.
Yeah, go on.
Okay. Concerning this T2 is directly proportional to 16.2 at a confidence interval. How did you get the confidence interval? From the graph. From the graph.
Yeah, so that's what exactly confidence interval means. This,
Yes.
you know, this range.
So how can we get it?
Yeah, exactly, because this is Python. Let's say in a data frame, you in a pandas data frame, each of these models basically becomes, you know, your, let's say, your columns. So you basically can compute the like the variance across in one row for those ones, and then that's your confidence interval. But the confidence interval is also here, so you can just specify where is the point that is like. So I think confidence interval really means it's like the 95% confidence interval is just tells you if it's one-sided, you go 90 like to a point where you have 95% of them covered. So it's really simple. You know what's confidence interval? It's basically you sort them into, let's say, from, if it's for the lambda we're talking, you sort them from minimum to maximum. So you sort them out, and then you compute what is the lambda value where I have 95% of the samples. You know, it's basically, let's say if lambda, this one is 100 points distributed, so it's a histogram, 100 points. Then you say where if I take, so if I just go to the 95 sample after sorting, what is the value of lambda there? That's the 95% confidence interval for lambda.
Okay.
Between the 0 and the 95. Is that clear?
Kind of.
I mean, it's really like an array. You know, it's like an array contains. This is just basically the different models is an array. You know, if you can sort it into columns or rows.
So I know with confidence interval, sorry, you have +1 and -1. So how do you get the plus value and the minus value?
That's called like, yeah. If this is kind of like that, you start from, almost always you start from the mean, and then you count. What does it mean 95? So it's basically it has to contain the around the mean. It has to contain 95%. So that means the tails are 2.5%. So then you go from one of the tail, like let's say, and then you go the samples that are 2.5% of the sample from the last point. That gives you the plus part. And then you go from the other side and you count 2.5% of the sample, and that gives you the negative part. So plus or minus is that one. So that's the minus one from the lowest and the plus one from the highest.
Okay.
And then the 95% means the 95% of the sample are concentrated around the peak with that interval.
Okay.
So if that is if you have this kind of Gaussian type. Sometimes if you have just only one tail, in this case not, but you could have, then you will only start from the beginnings. But that's why this plus or minus only satisfies for symmetric curves or Gaussian case. In this case, all of them are kind of like that, so it's okay.
Okay. So another question, please.
Yeah.
We're told to download the data, and then I was still saying something like BD and ED, please. Can you go over? I'm seeing something like BD, like beginning date and end date.
Yeah.
Is it different from the, first of all, we downloaded the data and we perform
Yeah.
some stuff. Are we to perform any exploration, like are we to do any
Absolutely.
data cleaning
I,
before we do
I have
this?
been I have been saying that a lot. I mean, again and again. That's what your main task is just going to be, to make sure to understand where is the date where you have 100 cases in the country that you're working. That is your beginning date.
Okay.
And then your end date is, as I specified it, it's where
this present day.
yeah. It's kind of the
Today, right?
it includes date from 25. So no, it's up to 25 July. So I specified, just for the sake of like to have enough validation data and test data, I specified until 25 July that you will use that one as your training sample from the beginning date. So this basically is the end date. 25 July becomes the end date. But you must make sure you have data in all that range. So that's where you have to make sure.
Okay.
Great.
So, and the validation is from 25th of July to present.
Exactly. So it's not, no, it's not from 25 July. So that should be the test one. I think, where is
Validation? Validation sets.
Yeah, but I think I specified here, right? So no, okay, that's not. Okay, does that I only, okay, includes dates to one final date in the yeah. Okay, so it's exactly yeah. The validation is to the point of the dates that you made the model. That is today, but then the test will be the next days. So that will be just until the 10th of August. So from that date that you produce the model to the 10th of August will be your what you will kind of test your model, because you don't have the data. So you will actually predict for that, and then you will compare if your model performs or not. Yeah.
Okay. Sorry, one more question. This statistics stuff now, I think I'm hearing a lot of things like machine learning, like validation and stuff like that. Are we really building a machine learning model, or
okay, so there's no such thing. Everything is, the model is a model, whether it's, and even the deep learning, Bayesian, or you're doing some kind of like random forest, they're all some statistical models.
Okay.
So it's
Nice.
just the naming is, we divide them in such a way that the way they approach is different. So we call it Bayesian when you are estimating parameters in a certain way. We call it machine learning when you are using usually optimization methods, and kind of like you do something, you get to, still you are estimating parameters. Still you are estimating parameters. Even if you are doing Bayesian, you are still estimating parameters. Even if you are making machine learning model, you are estimating parameters. You are running deep learning model, you are still estimating parameters. The parameters differ from one to the other, but that's it.
Okay.
It's in general, that's every machine learning is called parameter estimation, and everything that you compare between models is model comparison.
Okay, thank you.
Any other question before we close? So,
Yababel, please, about that bit, the training set and the validation set.
Yeah.
I don't really get that part.
Okay,
so
this is what actually, okay. If you are running it today, use the today as from 25 July to today as your validation. By validation, what do I mean? It's to know if your model really is kind of okay or not. It's kind of, it gives you a context. Like, let's imagine you use the data up to 25 July, right? You get parameters, and now you plot based on that. You plot your models, but you plot your models until today. You go on, yeah.
Okay, and what about the training set?
The training set is from the beginning date.
I'm not asking whether. Okay, from the beginning date to the 25th of July.
Yes, that's your training.
Okay, so
and you
that's the training.
specify
Okay,
them
so
on this.
I don't know about.
You specify them, and I don't know where my thing is. I don't have it here. So you specify it in the code, basically, by beginning date. The beginning date is the date that, you get, like where it's 100. And then the end date, you specify 25 July. And then the future, so the prediction is the prediction days. So the number of days you want to predict. So say it from 25 July to today, that number.
Oh, okay. So to get the validation set, I should calculate the number of days from the 25th of July to maybe, let's say, 10th of August.
10th of
the number of
today,
days I use
to today. Yeah, just make
Okay,
it
to
whatever
today.
to today. For that reason, that's why I say take 5 August as your the end date for validation. Okay.
Okay.
So 5.
Okay. So the number of days. So I should enter the number of days in the forecast where
Exactly.
I want to forecast.
Exactly.
All right. Okay. Thank you. Thank you very much.
That's Bill asked if interpolation is a linear regression. Yeah, it's kind of It's they all have different things, but it's a linear regression. Yeah. Because you have many types of interpolation. You can have cubic spline, you can have linear interpolation, blah blah. But yeah, you mentioned linear interpolation. Yeah, it's linear regression.
Okay. Hello, sir. I have a question, please.
Yeah.
Please, if you check please just go to the data description where you define our question, sir. Please.
Sorry, here.
Yes. You wrote here that it's unlikely, but if these dates have NN value, perform linear regression to fill this missing value. Make sure the final has a continuous date and ensure no date is missing. You now said 0 number of cases for given date is okay. So I don't understand exactly. If it's 0, is it okay or
no?
Like
I mean, it is okay.
Exactly
it is okay if it is 0, but the problem is that imagine, does that mean really that there was no COVID case when yesterday we had, let's say, 100, and then tomorrow you have 150, and today it's 0? Kind of that's why you need to do some linear regression instead of setting it to 0. But if the data, I have seen the Ethiopian case, it's complicated. Sometimes in one day they have nothing. It could be their testing problem, but in that case, yeah, okay, let's believe, you can either leave it as 0 or you can do some linear regression or linear interpolation. Is that clear?
Okay, so it's not compulsory we do the linear regression. That's what you're saying.
I think it is not. If you really want to complete it, yes. No. If you want to use your model for something really, to write a blog and kind of say something statement, maybe you should.
Okay, so thank you very much.
Yeah. So yeah, for me, it's just if you want to do the minimal work, I think, yeah, just set it to 0. Okay, awesome. Hopefully you got an idea, and I would really say just go on, and whatever question, just post it. Later, the tutorial at 3 will be by Jonas. Jonas is the first author of the paper, and he's gonna go through about the interpretation, how the different challenges in the interpreting the model. So yeah, don't miss it, because it will be recorded, but would be nice to ask. Huh?
When is the time for the meeting?
It's at 3. It's like the usual tutorial too.
Okay.
Yeah, just so that you can ask question if you want to, but he will just talk about the things you have to be careful in interpreting it. Okay.
Will he be going over the paper again?
No, he's not. He's just going to talk about some kind of the last part of the paper, the interpretation part of the paper. So basically, this part, the discussion, and this parts, the last parts. So which will be very useful for you in task 2.2. So in the task 2.2, what you're asked is, just to really interpret it, your result, and to give, blah blah. So that one for that part, you need to read as well their paper, this final discussion part, as well as the, like the interpretation part, and he will cover that. So,
okay. Please, one more question.
Yeah. Yeah, go on.
So I think I will ask the question when I remember.
Okay. So there's no question now. Great, guys. So hopefully, can you say it's doing posterior predictive checks? Elvis, are your questions answered already, or is there any question I missed?
No, you didn't say anything about it.
Okay, so what is your question? Because that's why it would be nice just for people to say it. What is the question?
It's that part where Stephanie asked about where you were saying we should plot the posterior. So I was just asking, can you say that someone is doing posterior predictive checks?
So okay, but I answered for Stephanie's. Did that answer your question or not?
Yeah, I got it.
Okay, great. Because yeah, it's posterior is nothing other than just saying. Usually, a posterior becomes a. I'm confusing you a lot of the times because I'm just saying something, but it's really a posterior is just nothing more than model, a model. Like what we call is usually the posterior distribution. What we call model is the posterior distributions of the parameters. That p theta given data. So that's what we call posterior. Okay. And
okay. Maybe a clarification.
Mm-hmm.
A clarification, maybe if you can navigate to the challenge description, please. Question E.
Yeah.
Question E, the one that you've just
modified.
Yes.
Yeah.
So when we're doing that, are we including the checkpoint, the change points?
I mean, it's up to here. It does include, right? So I would say, so there are 2 points. It's better to do them after change points, but I think if you just, for me, from my perspective, it doesn't matter.
It doesn't matter.
It doesn't matter. Like, so you could just, the only difference is what you're saying, that if you don't introduce the change points, what happens, the model would be, this lambda becomes flat. So it's kind of flat, but around that. So it's kind of, don't know if there is somewhere here. No. I mean, it becomes basically plot like that more than, yeah, I think they didn't keep it, but it will be like a lambda, just it could be a constant lambda. So it won't be like that. So this is because you model it as change points. Otherwise it would be like some kind of, I think. Yeah.
Hello.
Yeah.
Okay, so it's
I think
prudent
I think yeah, the point is just that produce that, but I would really ask you just to do it for both, or just yeah, whatever your choice, but do it with your final model, which includes change points. Yeah, someone was speaking.
Yeah, you said you wanted to react to your notebook yesterday. I don't know if you have made the additions.
No, I didn't, but if I did, I will just post it in Slack.
Okay, thank you. Yeah. That's my question.
Okay, so is there another question? Anything I haven't answered? If your question is not answered, just let me know. But if so, then yeah. I think this is great. I mean, I can tell you one thing. Bayesian statistics is the cornerstone of every, call it machine learning, deep learning, blah, blah. And it's a cornerstone because deep learning or machine learning, sometimes it may not have an interpretation, but there is a Bayesian field that tries to interpret everything, including deep learning. So it is the way to understand almost everything in data science it's kind of their Bayesian analysis is huge, like they're hierarchical, graphical, blah blah blah. But it's really the corners for understanding this thing would really help you understand so many things in the future. And you really, yes, it's 1 week. I don't expect you to understand more, but get just the exposure will help you. So it's kind of try to understand these basic concepts of what is a likelihood doing, what is a posterior doing, what is a prior doing, what am I doing, what is parameter estimation, and what do I do when we say model comparison. So that is the bigger picture of this project, and of course to make you produce something, but getting those basic concepts. Do I really understand? Am I appreciating this thing when people keep saying posterior, prior, whatever? What does that mean? What does it mean Bayes law? Because of the Bayes theorem is just a very simple theorem, but that's all. Everything about Bayesian statistics is about that. So did I understand? Did I appreciate the kind of the value of that? If not, keep asking until you understand. So that's my advice, because this is the foundation of every data scientist. I mean, to be a good data scientist. I mean, you can't be an okay data scientist with a rough understanding. But if you really want to go far, you need to understand, over time, not today. This week it's going to be a start, but over time you will understand the value of it. So just this week, get this basic appreciation of the Bayesian statistics.
Yeah,
Yeah.
Hello. If you can share some resources with us that deals with statistics physically and
I did share. I think I don't know if it's Biniam or somebody else. I think the book that I recommended is very good. So I think someone already got it.
Deepen my knowledge in statistics very well.
So I think that book, I think I will share it with you if it's not already shared. I think there was one person who shared it with me, and I asked them to share it in the resources. That book is one of the best books, at least for me to recommend. Simple, and it has a much of the core ideas.
Thank you.
Okay.
I have a suggestion.
Yeah.
I don't know if we out of context, but if you can get like a very simple example where you demonstrate from beginning to the end, using the Bayesian statistics. So you make a simple model, and then we run it. Okay, this is how we are training it. Here's the test. Here's the results, and these are interpretations. Can be very, very basic. So we see how the workflow goes, then we can apply it to the more complex thing.
It's excellent, but I would say just you guys should organize within yourselves, or invite somebody like to give. I think this is an excellent suggestion, but it's good that someone gives that kind of challenge, or you can ask your tutors to do that. Definitely.
Okay.
If there is enough requests, you kind of get together and say like, we need this thing, and is there anyone can give us some kind of like a small, very basic tutorial on that? I think that should be possible.
Okay, so anybody amongst us or tutors, if you're listening, we need that. If you can do that, that'd be great.
Yeah. But I think it's really it's a good thing. Organize it with yourselves and kind of do it. Definitely, it helps. It's very useful. Yeah. Okay. So I think Rofia, just you see that it's shared. So yeah, great. Awesome. Thanks, guys, and talk to you or chat to you soon. Bye.